Hello. Okay, now I'm going to discuss about parallel aiding. Okay, so this will come under magnetically coupled circuits. So we need to consider parallel coupling of two inductors as shown in the figure. Parallel coupling of two inductors as shown in the figure. Okay. So 1 and 2. So now what I'm going to do is I'm going to apply KVL for both the coils. So I'm going to apply KVL for both the coils. So let us consider KVL for the loop 1. This I am going to consider it as loop 1. This I am going to consider as loop 1. So we have voltage across these two inductors, which is V, okay, which will be common for both the inductor. We know it because the parallel connected elements will have same voltages. So first of all I am applying KVL at the loop 1. So what will happen if it is clockwise? I will get minus V plus the self-induced voltage is L1 di1 by dt plus mutually induced voltage due to the current I2 flowing through L2, okay, is M di2 by dt. Because the current I2 is flowing through L2, there is a mutual inductance which is linking the coil 1. Okay, so there will be a mutually induced voltage, okay, across the L1. We call it as M1 due to the current di2 by dt equal to 0. That is what we are going to get in the equation for the loop 1. So we can rearrange it. I will get V equal to L1 di1 by dt plus M di2 by dt, okay, which I considered as equation number 1. Next, apply KVL at loop 2. So here I am going to apply KVL. So now what I am going to consider is I am going to consider there is a voltage across this V. It is parallel. See, plus minus V, it is parallel. So I can consider the same voltage across L1. The same voltage will be appearing across L2 also. Okay. So I am going to apply, consider like this, and I am going to apply KVL. So I will get minus V, okay, because current is entering negative, leaving positive, plus L2 di2 by dt, that is self-induced voltage, L2 di2 by dt, and there is a mutually induced voltage due to the current I1 flowing through L1, okay, which I call it as M di1 by dt equal to 0. So if I rearrange it, I will get V equal to L2 di2 by dt plus M di1 by dt, which I consider as equation number 2. Okay, next I am going to apply KVL at node A. So this is my node A. Applying KVL at node A, I is the current entering the node, and I1 and I2 are the current leaving the node. Okay, you can see I1 here leaving and I2 here, which is leaving the node A. So I can write I minus I1 minus I2. Okay, I can write it as I minus I1 minus I2 equal to 0. So which can be written as I equal to I1 plus I2. I equal to I1 plus I2. Okay, now I am going to differentiate this with respect to time. I will get di by dt. Okay, if I differentiate I with respect to time, it is di by dt equal to di1 by dt plus di2 by dt. Okay, so now I can write the same equation, okay, for di2 by dt. I am just rearranging and writing di2 by dt will be equal to this di1 by dt will go to the right hand side. So di2 by dt is equal to di by dt minus di1 by dt, which I consider as equation number 4. Okay, so next di1 by dt. Okay, next I am going to find out what is di1 by dt. For that I can take this to the right hand side. So di1 by dt equal to di by dt minus di2 by dt, which is equation number 3. Okay. Okay, now I am going to equate this equation 1 and equation 2 because V is common. Both the left hand sides are same. So I am going to equate this 2. So what I will get L1 di1 by dt plus M di2 by dt equal to L2 di2 by dt plus M di1 by dt. So this is what I will get. So I am going to consider it as equation number 5. Okay, I am just equating because the voltage on the left hand side is same for both the equations. So I can equate the right hand side together. For the equation 1 and equation 2, I got equation number 5. Okay, now I am going to substitute equation number 4 in equation number 5. So if I substitute equation number 4 in equation number 5, what is equation number 4? di2 by dt equal to di by dt minus di1 by dt. Okay, instead of di2 by dt present here, I am going to substitute the right hand side value, di by dt minus di1 by dt. So I got this one as it is, L1 di1 by dt plus m. Instead of di2 by dt, I have di by dt minus di1 by dt. Okay, which is equal to L2. So instead of di2 by dt, I can write di by dt minus di1 by dt plus m di1 by dt. Okay, this I got. Okay, next I need to rearrange it. So I am going to keep all the di1 by dt on one side and di by dt on the other side. Okay, so I will be getting the equation like this. Okay, if I rearrange by keeping all the di1 by dt on one side and di by dt on the other side, now I can take di1 by dt outside. I will get L1 minus m plus L2 minus m. So these two minus m's become minus 2m. In this case, L2 minus m into di by dt. Okay, so now I can write di1 by dt is equal to L2 minus m by L1 plus L2 minus 2m. Okay, I can take this to right hand side, di by dt. So which I am considering it as equation number 6. So I consider it as equation number 6. Okay, similarly, I suppose to substitute this di1 by dt equal to di by dt minus di2 by dt in equation number 5. Okay, so wherever I find this di1 by dt in the equation number 5, so I have to substitute what? The right hand side value, di by dt minus di2 by dt. Similarly, what I have done while substituting 4 in equation number 5. Okay, I will go to the answers directly because it is simple calculation. So if I do that, I will be getting di2 by dt equal to L1 minus m by L1 plus L2 minus 2m di by dt. I got this answer. Okay, so I got what is di1 by dt and what is di2 by dt. So next I am going to substitute it in the equation number 1. So what is equation number 1? Okay, we applied KVL to the loop 1. So V equal to L1 di1 by dt plus m di2 by dt. So it is my equation number 1. So this I am considering here and substituting these two values, di1 by dt and di2 by dt. So di1 by dt is L2 minus m by L1 plus L2 minus 2m. So I substituted instead of this. So instead of this, I will write L1 minus m by L1 plus L2 minus 2m. That is di2 by dt. Okay, so now I can take L1 inside. I will get L1 L2 minus L1m. The denominator will be same. Okay, I can take di by dt outside because it is common. So I can take this m inside. I will get L1 m minus m square by L1 plus L2 minus 2m. Okay, so and both the denominators are same. So I will write L1 L2 minus L1 m plus L1 m minus m square. This L1m and this L1m will be cancelled. I will get L1 L2 minus m square by L1 plus L2 minus 2m di by dt. So this is what I will get for V. Usually if I have an inductor, okay, so the voltage will be written like this, L equivalent. If I have multiple inductor also, L equivalent di by dt. Okay, if I have multiple inductor also, I can find the equivalent inductance value and I consider it as L equivalent. So we can write V equal to L equivalent di by dt. So in the place of L equivalent, what we have? L1 L2 minus m square by L1 plus L2 minus 2m. Okay, that is my formula for equivalent inductance. Okay, in the case of mutually coupled coil. Okay, thank you.